Hey everybody, I am going to give you a little introduction to slash revisiting of measures of variation. So this is section 2.4 in our book. So variation is something that we definitely want to be able to measure as well as just appreciate. So we have looked before at this little dot plot. So here we've got, so I'm just bringing up my laser pointer here so I can tell you what I'm talking about. So we've got this data and we've got this data, and they have a lot in common. They basically have everything that we know how to do so far in common. So the measures of central tendency that we've been working on are the mean, median, and mode. And you can see that 40 and 40 here. So 40 is the median, so it's right in the middle for both of them. And it's also the mode, 1, 2, 3, 4 for set 1 and 1, 2 for set 2. And if we actually did out the math, we'd see that it was the mean or the average as well. And yet, when we look at it visually, we can see that they are not really the same. So this shape looks different than this shape. And if I just told you, hey, the mode and the median are 40, then you wouldn't know what you were in for when you're actually finding out, trying to like see what was going on here. So that is why we were doing standard measures of variability, because I could explain it to you, right? Like set number 1 is over here. It's got it's sort of clumped together. It's kind of got a tall shape when you look at the dot plot. Got all the numbers sort of scrunched together, like they're all bunched up. And then in set 2, they're really spread out, and there's not a lot of people who have the same score, for example. Usually there's only like 1 or 2 people who have the same score, so there's a lot of difference between people. Okay, that takes too long. So what we're going to do instead is figure out a standard measure of variability. So we know actually one thing that we can do already, which is the range. I think we've learned how to do the range before, but we'll revisit that briefly. And then we're also going to look at the variance and the standard deviation. And today we're only going to be looking at population. So there's a slight difference between doing it for a population and for a sample. So we're just going to stick with the population for now. And you can be following along in the slides. And I also have given you some handouts that you can use as well. So let's quickly revisit range. Okay, so that's the difference between the maximum and the minimum data entries in the set. So we've got, the range of a bass singer and a soprano singer is going to be different, right? Because their lowest and their highest are going to be different. And that's what we're measuring for a singer, as well as when we look at other things like, and so the other thing that's important is that we have to have quantitative data. So to be able to count. And the range formula is the max data entry minus the minimum data entry. Okay, so let's do it with our corporation that we visited before. So we've got a corporation that has hired 10 different graduates. Okay, so we've got these 10 graduates and we've got their starting salaries here. And we can see that this person has 41, but they're not making $41 a year. They're making $41,000 a year, which is a little bit more reasonable. And the reason that this is a population is because we're looking at everybody that this corporation hired. This could sort of be considered a sample if we had a different question. If our question was, do these 10 graduates, can we look at them and see, does this represent, graduates elsewhere? And I'm going to say this is just our cluster sample, but that's not what we're doing here. We're actually saying this is what we're interested in. We're looking specifically at this corporation and these 10 graduates, and we want to know some stuff about it. So we want to look at the maximum data entry here. So we're going to take this as the representation of the most, and we're going to subtract the one who has the least. Oh, poor little baby, only a little bit of money. And you know that that's what you look like, right? To me, when you graduate, you're still little babies. So that's the range. Okay, so let's see what that actually looks like. Now, it really helps to have our data in order. So I have shown you before how you can do that on Excel. And so let me just bring that up for you really quickly. I have for you here, let's see, will it drag over? Because I have to exit the slideshow 1 second. Cancel the slideshow. I'm going to discard my annotations, and I'm going to bring up the Excel sheet. So this is also for you in your file if you want to follow along. Zoom in on it here. So I've got your data for you right here. And so I'm going to go ahead and select this section, and I am going to go to the sort and filter button here. So I'm going to say sort. I'm going to keep the current selection because I just want to sort these numbers. I'm going to click sort, and I want to go from smallest to largest is what we tend to do. So, okay. All right, now it's nice and easy to look at. I can see that, you know, my smallest there is 37 and my largest is 47. So that makes things a little bit easier when we're actually doing it. So I'm now going to bring the slides back up if I can. So from current slide, there we go. So putting it in order makes it easier. Now we can see the 37 and the 47 much more clearly. So there's the 37, 47, and the range is just the max minus the min. So 47 subtract 37 is 10, which means that the actual range, remembering that these are, you know, it's a sort of shorthand. So the starting salary is about a difference of 10,000 from the biggest to the lowest. Okay. So let's think again about what it means to be deviant. I think we have some examples of that in society that we're maybe familiar with. So who is deviant? What is deviance? And these little pictures here give us a little reminder of maybe what that is in psychology or other places that you might have seen it, where deviance is just a little bit different, right? Somebody who's breaking the rules in some way, not behaving as everybody else does necessarily. And then somebody might be more or less deviant, right? So your grandmother might be thinking you're really deviant if you have a tattoo on your upper arm, but everybody probably in, you know, Dean College would think you're being pretty different. You're being very deviant if you have a big face tattoo, for example. So we can see that people can engage in deviant behaviors, but to like more or less of a degree. And that is also the case for our fun data. So deviation is going to be, in this case, the difference between our particular data entry, which we always call X, and then the mean of the data set. So what does that mean? Let's see. So for a population data set, the deviation of X is X minus mu. Remember that mu is the mean of a population. And for a sample, it's the same thing. It's just that now we have X, so the particular value of X minus the X bar, which is still the mean or the average. So I'm just going to highlight that for you. So the difference between the data entry X and the mean of the data set. So this is the mean for the population, and this is the mean for the sample. Okay, so how deviant are you? Is how far away are you from the norm? Okay, so we'll look back at our data of our 10 different graduate students, and so we've got our population here. So the first thing that we need to do is find the starting salary mean, because that's what we need to find for the difference. To figure out the deviance, first we have to figure out what's normal, what's a good measure of central tendency. And, you know, my favorite is always the average and the mean. So remember, this is the symbol for mean. And then you remember our friend sigma? Sigma saying add every single value up and then divide by n. So if I add 41 plus 38 plus 39 plus 45 plus 47 plus 41 plus 44, plus 41, plus 37, plus 42. What I am going to get is 415. So that's my sum of my different salaries, but I'm not done yet. To find the mean, I still have to divide by n. So what does n mean again? So we keep on saying n, we sort of think of as like number, the number of people in the population. And we know it's the population because it's got this big N instead of the little n, which we see with the sample. So our n is how many people are there in our population. And we could count up those numbers, or we could also just look right here. We can see that it's 10, but 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so we've got our sum is the 415, and then we're going to divide by n, which is 10. And so if we type that in our calculator, we type 415 divided by 10, and we get our final mean here, which is the 41.5. Okay, so now we've got our measure of central tendency. And now we want to know, okay, what's going on with the deviance? So this first person in our list here, and I'm going to go back to the laser pointer. This person who is making $41,000 a year, we want to find out how deviant they are. And you know what? They want to find out how deviant they are also. So they find out the average salary is 41.5. Now this person's making 41. So how are they going to feel about that? Are they going to feel like, ooh, I'm really deviant here? Or are they going to feel like, I'm pretty normal here? And so to do that, maybe you can just sort of have an intuition when you hear those two numbers and think, oh, those are pretty close together. So that person is probably not going to be feeling too bad about it, but they are feeling like, but I'm below the average, so that's a bit of a bummer. I'd be okay with average, but I'd rather be above average, if anything. So you can see here that shows up when we look at their deviation score. So we take their score, x, and we subtract the mean, which is 41.5, and we get negative 0.5. And remember, this is the formula right here, the x minus the mu. So this is x, the mu is our average, so it's 41, subtract 41.5 gives us the negative 0.5. Okay, so they're a little bit away from the mean, they're a little bit deviant. Every once in a while, you'll have somebody who is exactly average, right? So their deviation would then be 0. If there was somebody who was actually making 41.5, they're perfectly average, they're not deviant at all. But now let's look at somebody else. Let's look at this person who's making 37. How are they going to feel when they find out that the average price that people are getting paid by the corporation is 41.5? Oof, that might be a bit of a blow to the ego. 37 subtract 41.5 is negative 4.5. So it's pretty far away from that measure of central tendency. It's pretty abnormal or far away from the mean. So maybe they'd be like, oh man, I'm really not respected here. This is really upsetting me. I'm really deviant. But also they might actually just be really deviant, right? So we talked in class about how maybe that person is taking a job on purpose that doesn't pay very much because they don't really value money. They want to be out in the world, and maybe this is a job where they can like leave work whenever they want and have vacation time without any restrictions. So, they can go and tour with their band because they're in a deviant rock band. And so this person is far away from the average in salary, and maybe that's because of some deviant behavior, or not. Maybe they're just not making very much and they're bummed about it. So there's no inherent value judgment when you're far away from the mean, right? When you're far away from normal, sometimes that's a good thing, sometimes it's a bad thing, sometimes it doesn't matter at all. So we also have somebody here who's making 47, and so let's see what their deviance is. We take their score, so x, subtract the mean, so 47 subtract 41.5 gives us this time a positive number, so 5.5. Whew, really deviant again, right? Really far away from that average. So when they hear their 5.5 deviance, they're going to say, whew, okay, above average, nice, making a lot of money. I'm feeling really good about my comparison to everybody else. Okay, and you will also see that we've got our sigma here with the x, so that's saying that if we add up all of these numbers, we get 415, which we know because we found the average before, so those are all of the salaries. But we can also add up all of the deviances, and all of the deviances, we add up all these numbers right here, if we add them up, they actually equal 0, because there's some below and there are some that are above, but they all sort of are in relationship to that average. So the sum of the deviations here is 0. Now, I'm going to do the voice. Sorry, it's going to be even worse in video if I ever have to hear it. But the question is, what standard deviation is going on here? So we're looking at our data. We're saying, okay, we know the word standard. We know what deviation is now. So what is standard deviation? And the people who are in class really had to suffer through my forcing them to say it, and I wish that I could make you say it now, but maybe I'll send me voice notes or something. I'll say, what's standard deviation? And you'll say, it is a normal distance away from the mean, right? So standard is normal or average. Deviation is how far away are you from the mean. So the standard measure of deviation, what we're going to be doing is sort of conceptually looking for the average. So standard and average are also similar words. What's the average distance from the mean? And that is what the standard deviation is going to tell us. So before we start looking at it really specifically, let's look at what different standard deviations tell us. So the standard deviation is a number that's used to tell how measurements for a group are spread out from the average. How far away are they from the mean or from an expected value? So if there's a low standard deviation, that means that most of the numbers are very close to the average, right? So that there was that one person who was making $41,000 and the average was 41.5. So if there were a lot of people like them, then that means that the standard deviation is going to be really close to the mean. So low number means close to the mean, very close to average. A high standard deviation, on the other, it's the same measurement, right? How close are people to the mean? But this time, if it's a big number, it means that they're really spread out. So there's a lot of variation. So you can see those side by side in comparison. And so now if we look back at our original dot plot, we can see that we're still comparing set 1 and set 2, and they've got the same measures of central tendency, but now we have sort of a sense of what a measure of variability could be. So what would you say? Does set 1 or set 2, do you think, have a higher standard deviation? Because what is standard deviation again? It's the average distance from the mean or the normal distance from the mean. So which one has do you think, if you were to look at the distances from the mean, which one has more? And you can see this distance from the mean, this deviation, this deviation, this deviation. These ones aren't so far away, but these ones, they're getting pretty far away from the mean. So because of that, the average of all of these distances, or the normal distance, is probably going to be someplace in the middle on each side, right? So maybe kind of far away from the mean. Whereas for this one, if we look at all of these different distances from the mean, the mode is right there at average, which means that there's a lot of people that have 0 as a standard deviation, as a deviance rather. And these people out here, they still have a pretty small deviance. So if we look at all of them together, they're probably going to have a low standard deviation. This one's going to have a high standard deviation. So I'm going to just put that in there. I'm going to change the ink color because the red's bothering me. Make it blue. We'll say low standard deviation, because again, the deviances are relatively small. And then for this one, for set 2, this one has a high standard deviation, because these numbers, these deviances, are bigger than for this one. So that's what we're going to figure out how to actually calculate. Okay, so we've got a population variance and we've got a population standard deviation. Now, I know when you see those symbols, a lot of people freak out. You don't need to freak out. It's going to be okay. We are going to go through and walk it through step by step. But I think what I will do is stop it here, and then the next video is going to be walking it through step by step. So I just have to get to the place where it lets me do that. So stop recording. All right, talk to you next time.